This was something we commenced in late 2022, working with Tuohy and ACON to put together to try and get a carbon baseline from the work we had done on the N22 scheme. And so I'll take you through. First, I'll take you through the agenda. So firstly, I'll take you through the N22 scheme, give you a quick overview on the project itself. Then I'll run through the carbon benchmarking requirements for the scheme. I'll hand you over to Cathal, who will talk through the Cork NRDO record keeping app and the approach to benchmarking and TII's carbon tool. I'll then take you through the methodology and analysis for the carbon benchmarking of the scheme and some of the key outcomes that came from that process. Following on from that, Cathal will talk to you about carbon in future projects and some of our conclusions. We'll then open the floor for questions and answers. So initially on this N22 scheme, so the N22 is a road that runs from Cork City to Tralee. The project we're working on bypasses the town of Macroom and the village of Baile Bhuirne. It starts in the eastern end, just to the east of Macroom at Coolcower, and crosses across the existing N22 to head north of the village of Baile Bhuirne and ties in at Tuohy to the east of Baile Bhuirne. So I suppose the main parties involved in the scheme: Cork County Council were the contracting authority, Department of Transport were the funding department, Transport Infrastructure Ireland was the funding authority for the scheme, Monty McDonald were the employer's representative, John Craddock JB were the main contractor, and Barry Transportation were the contractor's designer. So this is some of the key points on the N22 scheme. There's 22 kilometres of Type 2 dual carriageway, the 2+2 road plus 8 kilometres of side roads. The total scheme budget was 280 million. There was 190 hectares of land, including final Kerry slug habitat, which is 19 hectares, which was compensatory habitat. There's 120 compulsory purchase orders of landowners. There was 4 junctions in the scheme, 3 of which were grade separated and 1 at grade. And the earthworks volumes there was 2.42 million cubic meters of fill, 2.9 million cubic meters of rock, which included 1.2 million cubic meters of rock. So some of the key structures, it was a very structures heavy project, and you can see the SO2C overbridge here on the right hand side of that photograph. So there was 4 river bridges, 12 underbridges, 5 overbridges, 53 culverts, 21 accommodation structures, and 8 retaining walls. So the timeline in the scheme, so the scheme first started to come around in 2009-2010, when there was a first application on Board Panola, and there was an oral hearing in 2010 on Board Panola. Approval was received in 2011. Judicial review was completed in 2013, with a notice to treat issued in the same year. The enabling works for the scheme commenced in 2017, with a further on Board Panola approved for the version of the 110 kV line in 2017. Tender docs were issued in June 2019, and the tenders returned in December 2019. A letter of acceptance was issued following that. So the construction timeline, it was the letter of acceptance issued in October 2019, with a start date of December 2019. The Macroom bypass, the first section opened to the north of Macroom town, was opened in December 22. Another section was opened to Tuohy in August 23, and the third section was opened. The final substantial completion was in November 2023. So I'll talk through some of the carbon benchmarking requirements from the scheme.
So just delivering on Ireland's climate ambition. Why benchmarking? Ireland is committed to achieving climate neutrality no later than 2050, with a 51% reduction in greenhouse gas emissions by 2030. The benchmarking is to strengthen climate action reporting in public sector bodies. These legally binding objectives are set out in the Climate Action and Low Carbon Development Amendment Act 2021. The Act commits Ireland to move to a climate resilient and climate neutral economy by 2050, in alignment with the European Green Deal. So since 2019, the Government of Ireland has established climate action plans, providing an implementation plan on how to deliver on these commitments, with further plans were delivered in 21, 23 and 24. So there are the 4 plans that bring us up to this year's climate action plan. So Can we measure it? And I suppose the answer is yes, we can. TI have been looking to establish a series of benchmarks for the volume of carbon in different components of their road projects. In late 22, TI and Cork County Council commenced discussions relating to the as-built data, record data that Cork had been collating for the N22 Baile Bhuirne to Macroom Road Development. We had been collating the as-built data since the commencement of the project, which we had carefully assembled to correspond to TI's series of roadworks. TI's view at the time was that they had never seen such a detailed data set containing many of the primary elements which they required to establish their benchmarks. So it was agreed at that point that we would commence working with AECOM, who are the consultants for TI's climate guidance and who also developed TI's carbon tool. Jointly, we were tasked with undertaking a comprehensive study to quantify the emissions from a range of road elements, thus enabling TI to have a series of carbon benchmarks for these elements. Typically, which Kiely will go into in greater detail later on, these were broken down to the main line, structures, junctions, and side roads. And eventually the benchmarks were to enable TI to, at a strategic level, plan against anticipated sectoral carbon budgets, at a project level, provide high-level carbon estimates at early design stages, so in your optioneering stage, and provide a benchmark against which to compare, validate the carbon performance of other Irish road schemes when practitioners are using the TI carbon tool. So the carbon tool itself was development of the N22 carbon benchmarks was conducted in accordance with the PAS 2080 TI carbon management in buildings and infrastructure. So over the course of this presentation, we'll be discussing the life cycle stages. So if you see the letters A1 to A3, that's what we primarily were dealing with. So you have your embodied carbon, which is made up of your construction materials. So that's the embodied carbon associated with the construction material quantities, the transport of materials. So that's the carbon associated with the transport of construction material to the site by vehicle type. Probably one of the easier items we'll probably address today. The plant, then the rest of the embodied carbon is associated with actually construction activities on the scheme. So these are all in the A5 section. So there's plant use. So that's the carbon associated with the litres of fuel used by plant and equipment during the construction phase. So i.e. that's a total fuel use per piece of equipment per function. The employee commuting, the carbon associated with the transport of site operatives to and from the construction site for different transport types. So the total distance they travel and how. Clearance of demolition activities, carbon emissions associated with the clearance of demolition activities before construction of the road scheme, and that's hectares of land cleared per land type. Then there's the carbon emissions associated with land use change associated with the construction of the road scheme, the loss of forest, peatland, etc. And finally, there's the excavation, the carbon released during the excavation process. So that's just a volume of earthworks material. So I suppose just a bit of detail on the PAS 2080 is 2023 carbon management in buildings infrastructure. This is the global gold standard for carbon management in infrastructure since its release in 2016. The current version of the new world's first is now the world's first framework to unite both buildings and infrastructure for the decarbonisation of the built environment. So back to the life cycle stages for the civil engineering element, which obviously the bypass is related to. So if you have the A1 to A3 stage, which I'll go into further detail in the next slide, is the raw material stage, kind of internal transport and the manufacturing. Then you have the A4 transport, which is the transport to site, which Cian will cover. And then there's the A5 is the actual construction processes. So what is embodied carbon? The extraction, processing and transportation of project materials requires energy and releases carbon, resulting in embodied carbon. Embodied carbon is the carbon dioxide or the GHG emissions associated with the manufacturing and use of product or service. So well, a not so simple example is structural concrete. So A1, this is how we come up with the carbon embodiment figures or the emissions factors per cubic meter of structural concrete. That has to take into account the mining at the raw materials, so your initial excavation, then you're into your factory processes. So you have your limestone, added heat, clinker, you SEMs, which is your GGBS, possibly cement, aggregates, water, and all the air, and the mixing together all comes out with an embodied an emissions factor. So for every cubic meter of concrete, we're talking about 329 kilograms of carbon dioxide per cubic meter. So that's 0.32. So for every cube of concrete, you're talking about 0.329 tons of carbon. And then the other stage is A4. There's a little concrete truck delivering concrete to site, and the use is in the construction stage is A5. So A5 would be your fuel burn to actually, let's say for that particular concrete, it would be your fuel burn for your craneage and or any other item associated with actually depositing that concrete into its form. So I suppose to get to the stage that we actually were able to have the data available for TI, we developed in 2020 a mobile software app by Geopal and also it was the site team utilised the Geopal app to undertake our site records via tablet, which was site-specific locations, label, plant, activity detail, delay details, weather, and I'll just run through to there. So we were able to create a site form basically based on the typical allocation sheets used on several previous projects, whether from the private sector or from other road jobs. We amalgamated them to one form and went out to a developer so they could get the best of all worlds. Prior to going live, we had it independently verified by Stabilies, who were TI's consultants at the time. So you can see here how on any item of the project, we can upload details on excavations, what text of what work is doing. I'm doing a bit of fast there on the right, but you can write in your delay details, the change location, just typical details that you'd associate any record on site. And then so look, delay in the morning for late delivery for pipe subcontractor. So you can go into change, and then you go into the selecting the plant and trade, which is your operative's name and the plant associated with them, if they had plant associated with them. So the beauty of this item is actually creates an as-built program for the works. So over the course of Macroom, since it actually went live at the end of 22, we had over 25,000 records taken using this platform for daily items that were occurring. So you can imagine the volume of work that took several staff to undertake this item every day. You can see the name of the plant, and you can see an item of plant being associated with that person. So over the course of, you can see at the peak of the N22, we had up to 450 items of labour and plant, made up of roughly at the peak, which was August 2021, 300 operatives on the ground, and roughly half would have been associated with various items of plant. So the beauty of the whole system is the end product is the Microsoft dashboard that's available for use. And I'll just on my little laser pointer. So that can basically, at the click of 3 or 4 clicks of a button, now we can get every item of analyze every item of information that's available for the Macroom bypass. So if I wanted to go in and look at any, let's say, element of, I want to look at a bridge structure. I picked, there was Macroom was split into 3 sections. I want to look at a bridge. I select the bridge item, and within maybe, I don't know, 10 seconds there, I have all the records on that structure to my hand, and also an as-built program just by clicking those based on the work that had been done on the site. Likewise, look, you can see the tables here. They're all the total hours by plant. So you can see every item of plant that we have recorded, they're the total number of hours, going from some items that would have been constantly in use, 40-ton dumpers, down to items that have been there for a couple of days. And this is the analyzing tool. So Macroom is split into 3 sections. So if I wanted to go in and look for any full records for any structure, I can go in and drill down and analyze. So I want to look at bridges in section 1. So I'm going to select that point as a table. they're all the bridges in that section. Now that's Cian will bring you through in greater detail, but that was the largest bridge on the structure 3. So within, I don't know, 10 seconds, I have all the data associated with that bridge to hand. Likewise, if I want to go look at earthworks on the project, I can go back out now and select one of the largest cuts on that section of work, click into it, ask for export the data, and within a couple of clicks of a button, I have the full as-built program and the labour and plant associated with that structure. So you can see it's all about the information you put in and the value of it you get out at the end stage. But like that I suppose it's supposed the way yeah, let's go on to the next slide now. Oh, sorry, I have to go back out of the laser pointer, apologies. And so Cian will now bring you back down to the approach to benchmarking.
So here I'll probably take you through some of the some people might find it less intriguing, less boring. It's some of the more further detail on the benchmarking. So I suppose the approach we took to benchmarking. So for what role components did we develop carbon benchmarks? So from the information that we provided, the N22 site team provided, the ACOM team through consultation with TI developed carbon benchmarks for the following elements: combination overbridges, underbridges, junction bridges, river bridges, combination underbridges, combined underbridges, pedestrian underpasses, culverts, junctions, side roads, and mainline. And carbon benchmarks represent the average volume of carbon for a specific type of structural element. And where possible, this benchmark was averaged for 4 examples of each type of structure. That wasn't possible for all types, but that was the aim. So the following approach was used to develop a series of carbon benchmarks for the scheme. So initially, the data was collected. This was the N22 site team function. So we collected the data Cathal spoke about earlier, and we put it into a format which was usable for ACOM. That was work that was carried out. We broke it into individual structures or elements. So following that, ACOM took our data, the raw data, and converted it to enable correct emissions factors to be applied to it. This data was then entered into TI carbon tool, and quality assurance was carried out throughout this process. And where required, there was some materials which we would have highlighted through our analysis of each structure that would not have been included in the TI carbon tool. And these emissions factors were added and have now been added to TI carbon tool. So there's a good representation of all the materials that are required in a road scheme now within the carbon tool. And then there was ACOM would have done further data analysis and aggregated and analyzed the data, a carbon benchmark, an average volume of carbon per type of structure, a carbon benchmark per unit structure, i.e. per square meter of bridge deck. So this was all done in collaboration between the N22 project team, ACOM, and TI throughout the process. So another item we looked at was the transport of people. This is basically how everybody working on the project got to site every day. So this was an unusual thing in that we had to figure out where everybody in the project worked, how far they traveled, how they traveled to work. So we did this by surveying staff on the site for a day and recorded their transport modes. Some people would have only traveled on a Monday and Friday and traveled lesser distances during the week. So there was a good few quirks to this, and I suppose the figure we came out in the end was the average kilometers per operative per day was 96 kilometers. So we extrapolated this over all the man days that we had recorded on the scheme. This was an interesting fact is 50% of people traveled by car, 45% of them by van, and only 80% of the people on the site carpooled. And the remaining percentage, which is a very small percentage, traveled by bike and public transport. I suppose the scheme in Macroom was a very rural scheme, so it probably wasn't available to people. A lot of people traveled by public transport or even by the infrastructure probably wasn't there. I suppose there was certain assumptions made in this as well. So you can't pick up exactly how everyone travels somewhere every day. So it's making assumptions, and it was so then materials. Another item we had to gather together was all the materials used on the site, as well as how those materials got to site. So I suppose initially we started off with a schedule of elements and structures on the scheme. Then we put together quantity takeoffs for each element and structure. And on top of this, then we had the TI carbon tool emissions factors. So all of this data aggregated together by ourselves and ACOM came up with I suppose the big thing on this was the transport of materials, transport of materials to site. I suppose one of the biggest items of transport of materials to site was the transport of the long span beams, which were a particular element of the scheme in the N22. So these were 49.9 metre long beams that travelled from Banagher in County Offaly to the site in Macroom. This is a video just documenting their travel to the site from Banagher. This is National Geographic did a feature on this structure from Ireland from above and how it was constructed. Some of the footage from that is featured here. You see them. This is Banagher's yard in Offaly. It was a 500-kilometre round trip for these. Each individual beam was transported. So some of them travelling through and heading onto the motorway section here, and heading into Jack Lynch Tunnel through the old Dunkettle interchange, as it was when those beams were transported in late 2021 into Jack Lynch Tunnel and transported to the N22 site. So this was the beams being lifted into place at the Lady River, 150-ton, 50-metre beams. So I suppose some of the key outcomes from this was the materials came from all over Ireland and overseas. It's typical. Some of the RE panels and beadworks would have come from Northern Ireland. The reinforced steel came from Meath primarily. Precast beams, as I said, came from Banagher in County Offaly. Some pipes from Tullamore in County Offaly. The culverted pipes primarily came from Macroom in County Limerick. Our blacktop and concrete came from Killarney, and also the blacktop came from Carrigtwohill. Concrete and aggregates were sourced close to sites, only 14 kilometres away, and the structural steel for the main structure in the scheme came by sea from Spain and then overland to the site. And some of the key numbers I'd say from this: on the main line, the transport of materials for building the mainline roadworks, there was 1.7 million kilometres of mainline of HGV transport to get that to site, and 155,000 kilometres to side roads. The culverts in total involved 215,000 kilometres of transport to site, and the river bridges 621,000 kilometres to travel to site. So I suppose this is some of the boring information from each of the 33 benchmark structures. Raw embodied carbon was downloaded from the TI carbon tool to undertake the carbon analysis. The embodied carbon emissions were categorised against the 17 TI series from series 300 to 2400. So some of the key outcomes I think people will find interesting from this is the benchmarks that we have developed for each of the structures types. So, and we've broken this down, which will be very useful for people in the future at early stage schemes, of the tons of carbon per metre squared of deck area for different structures types, from the accommodation over bridges at 0.8 tons per square metre. We went up to the junction under bridges 6.78. They were short and tensor, and some of the river bridges, which were 3.22 tons of carbon per square metre. So another interesting fact that came out of this analysis: two of the main bridges on the scheme, the S28 Land River Bridge, which was a 100-metre long two-span bridge, and the SO3 Bowl River Bridge, which is a 120-metre long two-span bridge with a weathering steel superstructure. The S28 Land River Bridge had a pre-stressed superstructure. So one of the key items was that the carbon, the embodied carbon for the weathering steel structure was less than half that for the pre-stressed concrete structure. This is a big learning for people at early stages of development schemes to look at this and see what is the best way of reducing their carbon within their structure. What are the best structural types to look at? And I think we've put together information which is very useful for people in that element. When we broke it down by series, you can see that the road drainage system, approximately 6% of the total embodied carbon. Similarly for drainage and service ducts. The road pavements between the cement-bound mixtures and the bituminous mixtures at approximately 20% of the embodied carbon. Structures in this scheme were nearly 60% of the embodied carbon. This is very high, but I suppose given the level of structures in the scheme, that is not surprising to us. Similarly, the drainage and service ducts On first examination, people felt it was a very high figure. I suppose when we looked into that further, it was probably the fact that it was 36 kilometres of concrete surface water channel incorporated in the scheme, which would have raised that significantly. Similarly, we would have expected the bituminous materials to be higher, but given that there was a cement-bound base course used for the road pavement, that increased that figure under the Series 800 significantly. Similarly, as I said before, the structures is some 60% of the embodied carbon, given I suppose the scheme had twice as many structures as a typical road scheme of the same size. Another interesting item came out of it was the material inactivity analysis. So as you can see, the aggregates, cement and concrete is the biggest item of the footprint at 47%, and plant use then was the next biggest at 26%. This was the breakdown of this is the construction activities are approximately 1/3, whereas the materials account for 2/3 of the carbon footprint of the scheme. So, and I'll just go through here. That 86% of the embodied carbon was derived from the construction stage, and the maintenance accounts for a further 14% of the total carbon footprint of the scheme. Figures which may be of interest to people here is there's figures developed per kilometre of road here and per lane kilometre, which are planned to be used for people at early stages of schemes in the future. So if people are putting together work at phase 1 or phase 2, they can see what their scheme will potentially, what the carbon footprint of the scheme will be, depending on the per lane kilometre or the per kilometre road, depending on road type. So I suppose TI's head of environmental policy compliance in Somali was very happy with the work that's done this, and I suppose he said the work has significantly helped to get a greater understanding of carbon emissions during the construction phase or project.
So carbon and future contracts. I suppose currently we're dealing with a number of upcoming major projects in Munster that are going to be done under the NEC type contract. You can see here there's a use of the NEC 4 engineering and construction contract. Option C on upcoming major projects, and ones come to mind are the M28 Port Ring Kiely and the Adair advanced work section that's due to commence next year. This contract now introduces reasonable and achievable climate change requirements. In these contracts, there are secondary options, which are X29 climate change clause to incentivize initiatives to reduce carbon emissions, potential use of performance tables in contracts to reward such incentivization and reductions in carbon, so your KPIs. We'll be providing a carbon reporting platform for contractors to upload and report on their monthly carbon usage. And now we're adding in requirements for contractors to have sustainability managers outside of the standard kind of environmental managers to promote ideas of carbon reduction and ensure all carbon reporting requirements are met. So that's just, we're working on a platform for a current project we're on them, and just their mock-ups that we're kind of getting our head around to be able to like have a good visual of what the monthly carbon that you can go in and dissect and analyze throughout the currency of the project. And hopefully we won't have to return to how we had to do Macroom, but it's going to be done on a continuous basis over the next 3 years. So we'll have even further data available at our fingertips as the projects come in and continue. So other ideas for carbon and future projects is the future use of the carbon ladder. So you're going to hear that term coming up in the future. So you have your level 1, 2, 3, 4, 5 on the carbon ladder, and I'll go through them in a minute. So the CO2 performance ladder is a certification scheme developed in the Netherlands to encourage companies to reduce carbon emissions. To achieve certification under the CO2 performance ladder scheme, contractors have to undertake several steps to demonstrate how they will reduce carbon emissions. The higher a tender's ambition level on the ladder, the higher the reward the tender receives as part of their MET criterion. So it's a kind of comparative cost reduction they're allowed to have. And then successful tenders would have to substantiate their level of the ladder early in a project by providing CO2 awareness certification. And trials are underway in 2024 on the TI network framework on the use of this carbon ladder. So levels 1, 2, 3. I know there's a lot of levels today, and this is another level, and there's but level 1, 2, 3 concern the carbon management and challenging reductions targets in your own organisation. So how a contractor could affect their own organisations. Typically, these are your scope 1 emissions, so your company vehicles or your company buildings. When you get further up, level 4 focus primarily on contributing to carbon reduction within the chain, as well as innovation. When you get to level 5, I think this is going to be it might be easier for the bigger contractors. The company shows that it's achieved the ambitious level and targets which is set for itself. So level 5, you're really be able to go down into the supply chain. So the bigger contractors out there, the major top tier contractors could go out and affect the market in terms of dealing with suppliers and stuff. So you have your processing products, typical the large scale emissions, they can go and affect that. So they may be able to achieve level 5 on the carbon ladder. So sorry, at level 1 the ladder, a contractor would be impacting the emissions within their own organisation, and at level 5 you'd be impacting emissions down the supply chain. So as a conclusion, so this was TI's climate action roadmap published in the middle of this year. So TI carbon tool was used to undertake, this is an extract from it, the TI carbon tool was used to undertake a detailed carbon assessment on the N22 Baile Bhuirne to Macroom project with granular data and materials associated with the scheme accounted for. Therefore, the assessment can be used as a detailed benchmark for future projects. The type of benchmarking will enable estimating carbon more accurately in the early design stage and facilitate the identification of potential carbon reduction on similar schemes. The assessment is expected to be completed in Q3 24. So that was just at the opening of the Macroom bypass last year. So TI Chief Executive Peter Walsh on RT News website. The press release, the project was innovative in many ways, including the use of the carbon tool to record its footprint, which will be a significant benefit in the planning of future projects. So just our final conclusions, carbon management is becoming a mainstream practice. Clients and contractors are starting to show a real commitment to reducing carbon. Carbon reduction must be integrated into the decision-making process at every work stage. The biggest changes in carbon can be made earlier and at the optioneering stage of a project. It's very hard when projects are about to go to tender to make significant changes. They've already got planning at that stage, and moving away from something it's a lot easier to make the big savings in the feasibility stages. So one thing myself and Cian have grasped is the clients will need to have a strong grasp of the realistic carbon numbers for their schemes going forward. I suppose when you look at what we would say the carbon associated with the specific construction of the scheme, which is the A1 to 5 stage, I think we were totaling about 137,000 tons of carbon. But if we decided to remove all the earthworks associated with that project, that was, I think, over 20,000 ton reduction. That's still only 15% reduction. If I remove the largest bridge on the scheme, which was, I think, the steel structure was I think was a 4,000 Cian. So you're talking less than 5% of reduction by removing the largest. So reductions are very hard to actually change. So like, if you aren't able to know what your carbon baseline is going forward, it's an important thing the clients will have to get their head around and pretty quick. So in future, we'll be no longer primarily talking about the financial cost of a project, but we'll be talking about the carbon cost of a project. So I suppose it's why we're here today, and there's the sustainability series in October. So just to conclude with acknowledgements, I suppose, was AECOM, who were TI's consultants, Lauren Harrington, Ian Davis, Illyri Brown, TI, we had Billy O'Keefe, Dr. Vincent O'Malley, Jim McCarthy and Yanzi George, and for Cork County Council, we had Ronan Keane, Ronan Spillane, the N22 site team, and Sean Callery. And that's the end of our presentation.